let's just do one example, as evil as I possibly can think, of advanced trigonometric substitution. Now, down here, okay, U substitution doesn't work, everything else is exhausted. Trigonometric substitution, you're our only hope. This is sort of like 1 minus x squared, so it's sort of like x equals sine, but we want that 5 to go away when we square it. So we divide by the square root of 5, and we want to be able to factor out a 4, so we put 2 over square root of 5 sine of theta. So dx is 2 square root of 5ths cosine of theta d theta, and we put everything in. We end up with x squared up top is 4/5 sine squared of x. Dx is 2 square root of 5ths cosine of theta d theta, and then down here, let's write it out. 4 minus 5 times x squared. We've just written x squared. That is 4/5 of sine squared of x. Now those 5's go away. Die. We can factor out a 4. And so we have, let's see, I'm going to take this and this out front and get 8 over 5 root 5. Up top we have sine squared theta. Shame on me, these are thetas. Sine squared of theta, cosine of theta d theta. That's everything up top when those things have been taken out. Down below we have square root of 4 minus 4 sine squared. That's 4 times 1 minus sine squared of theta. And that 1 minus, well, let's put it right here. 8 over 5 root 5. The square root of 4 comes out as the square root of 4. Integral of sine squared theta cosine of theta d theta. And 1 minus sine squared is cosine squared. Square root is cosine squared is cosine. Oh, blar. Okay, so what is it? This is 2, so that cancels out with that. And so we have 4 over 5 root 5. Integral of sine squared, which is 1/2 1 minus cosine of 2 theta d theta. Bring that 1/2 out front, and we get 2 over 5 root 5. Actually, the integral of 1 is theta. Whose derivative is that? 1/2 sine of 2 theta plus c, right? Because the derivative of sine of 2 theta is cosine of 2 theta times 2, and the 1/2 will cancel out with that. Lordy, 2 over 5 root 5. What is theta in terms of x? Oof. X is 2 over root 5 sine of theta. X is 2 over root 5 sine of theta. So theta is root 5x over 2. Nope. It's the arc sine. Arc sine of root 5x over 2. And if I draw the triangle, I want what? Sine of theta is root 5x over 2, so root 5x over 2. Oof, I'm going to use the Pythagorean theorem out a long way. B squared plus 5x squared is 2, nope, is 4. So x squared is, wait, no, I'm solving for b. Right, so b is 4 minus 5x squared square root, which 4 minus 5x squared square root is what we had in the original problem. Oof. Anyway, what was theta? Theta was the arc sine of root 5x over 2. We use the sine of 2 theta is minus 1/2 sine of theta cosine of theta plus c. Use that identity, and we're correction. The sine of 2 theta is 2 sine theta cosine theta, so that this half and 2 cancel out, and so we are left with 2 over 5 root 5 times the arc sine of root 5x over 2 minus sine of x is, sine of theta is root 5x over 2. root 5x over 2, and the cosine of theta is adjacent over hypotenuse, the square root of 4 minus 5x squared over 2 plus c, and we could combine those 2's to get a 4, but really, why bother? There's the answer.